Welcome back. We are in week 11, pursuing testing of web applications. In the first lecture of this week, I had introduced you to a very high-level introduction to web applications, talked about the issues. The main issue is it has a numerous set of technologies, so it is not the same as testing an individual program. Testing static websites is what we saw. Now we're going to look at dynamic web applications, which have a client and a server, and are going to start with client-side testing of web applications. So, as I told you, dynamic web applications have a client and a server. A simple way of understanding what a client is, let's say we all have accounts in a particular bank, let's say the State Bank of India. And we all are used to internet banking. So the State Bank of India has several users who use internet banking. And they can use internet banking from their laptops, from their mobile phones. When they open the SBI page, let's say on their laptop or PC, then they are a client. They represent one client. And State Bank of India has a server where all information about banking, internet banking users, account holders, are stored in a server. So when I do client-side testing, I'm testing for the user interface, the way these clients or users interact with the server, and how does the server respond to their interaction. So that's what is client-side testing. When I test for server, I test for the software on the server. I could do unit level testing, system level testing based on the programming language that the server software is written in. As I told you, the user interface is on the client and the actual software is on the server, and they are almost always geographically separated. If you take the same internet banking website, different clients or users can access it from different cities, towns, villages, on the move, while driving or in a train, whereas the server of State Bank of India will be located at a particular location. Testers typically have not access data to state or specific data on the server without authenticating themselves. As a tester also, they have to do that. Otherwise, it's difficult to access the server and can cause security breaches. So we see what are all the common client-side testing that we have. It is also to be noted that web applications are developed using numerous technologies. Java Servlet, JSP, ASP are there, and then came JavaScript and versions of JavaScript, React.js, AngularJS. Now we have Node.js for server-side programming. So the technologies for developing web applications keep evolving. A testing technique, if it's very, very specific to a technology, will very soon become outdated because the technology gets outdated fast. So when we look at client-side techniques, we are going to focus a lot on black box client-side techniques. If you look at the title of this slide, it says black box client-side techniques. By staying black box, I'm safe because I'm not hooking myself to a particular client-side application development technology or platform. I still can write interesting test cases for web applications, but it's not heavily specific on JavaScript or JSP or anything like that. As the technologies changes, I will still be able to design test cases and test a web application. So we're going to focus a lot on learning black box client-side testing techniques. So what does client do? It basically provides inputs to a web software, and web software always resides on a server. How do I provide input? I'll open a web page, and that web page gives me a form. It could be a simple thing like searching for something on Google, or it could be a login screen where I log in to do internet banking, or it could be searching for a particular product on an e-commerce platform. Whatever it is, there's always a form available, and that form is rendered using HTML. That form usually has text boxes for me to enter text. It might also have buttons, radio buttons, for me to choose which option I want. It could have a drop-down list. For example, if I'm typing address as a part of a form, usually the name of a country, the name of a state in a country could be given as drop-down lists because people tend to make spelling mistakes when they type the name of a country or type the name of a state in slightly different ways. Like for example, if I type Uttar Pradesh, then I might type it as Uttar space Pradesh. Somebody might type it as UP. Similarly, Andhra Pradesh, they might type it as Andhra Pradesh or AP. So to avoid that, people give drop down lists so that it standardized names. They can also be links. So all these are used to fill up a form that is rendered through HTML. That becomes input to a dynamic web page. The forms could be just a simple search button, could be username, password, and a CAPTCHA, could be username, password, age, several different things. Could involve addresses, whatever it is. So there are text boxes, radio buttons, drop-down lists, links, everything given. All these inputs are collated, sent to the server, and the server provides a response. I want to test on the client side. So to test for the client side, I have to provide inputs, and inputs are always given through forms. So I could randomly understand the domain and cleverly design my own inputs based on the domain. Like for example, suppose I'm testing a banking website, I could design my own inputs. I could randomly choose inputs. Suppose I'm testing an e-commerce website, I could design my own inputs or randomly choose inputs. Those are okay. They don't need us to learn any particular techniques. Those are the first two. Or the other thing that you can do is, typically if you notice, web pages will store a lot of your browsing history. Suppose you had searched for, let's say, a particular product on an e-commerce website, let's say a pair of shoes, let's say. And irrespective of whether you bought those pair of shoes or not, next time you go to another website, let's say to read some news online, you typically find these banners that keep advertising for the products that you recently searched for. A web page knows these things. Your browser knows these things. And how does it know it? It keeps some amount of data based on your past history. That data is called user session data. From the point of view of testing, user session data becomes a very rich source for us to test. There could be other users of the same software, or it could be an earlier use of your software, and I can test based on user session data. That's one module that we will see. Another way to test is what we call bypass testing. So typically, client inputs are sent to the server, and the server response is rendered as a web page back to the client. For invalid inputs, the inputs that are considered wrong, client always runs some scripts or constraints to check if the input is correct. Because if I send an invalid input to the server, it might end up corrupting the data in the server. So the idea in bypass testing, which is the technique that we are going to learn in this lecture, is basically to purposely generate wrong inputs that violate the normal format of the input and bypass the client side checking of those wrong inputs and send it to the server to see how the server responds to those client inputs. Let me give you a simple example. Suppose I'm searching for something in a search engine like Google, right? And while searching, I make a spelling mistake in that term. How does Google respond to this spelling mistake? Google's response is very robust. It will correct the term that you're searching for, substitute it with the right spelling, and tell you that it has done that, search for that corrected term and give you the response. So the goal of bypass testing is to purposely generate wrong inputs, violate the client side checking of those wrong inputs, send it to the server to see how robust the server is. So that's another technique that we will learn. So we will learn testing based on user session data. We will also learn bypass testing. So what is bypass testing? As I told you, web applications impose constraints on inputs through HTML forms. So let me just give you an example. I'll come back to this slide. So let's say this thing that you see on this slide, imagine it to be a simple user interface of a web page. So there is a web page, there is a form given as a part of the web page, and you're asked to input username in the form, age in the form, and maybe you're buying something and you can buy 3 versions, either the small version of the product or the medium version of the product or the large version of the product. So these are radio buttons. Under nominal circumstances, for a correct input, you would expect the username to be a valid name. It should not have special characters. You would expect age to be a valid age, let's say some number between 18 and let's say 100, and then one of these versions to be chosen. So this is the user interface that provides a form for a client to fill up some information. What is going to be the code underlying this form? If you look at the code that underlines this form, that will look something like this. I'm just giving you a fragment of that HTML code. So I will help you to read it. So it says there is a form. That's what is this tag form that begins with. And it says input. There are 3 inputs that it form has: username, age, and the version to purchase. Username as an input is a text. Age as an input is another text. Version to purchase is a radio button. So it says input type is text, the first line, and it takes a username, and it says size is 20 characters. Some restriction, maximum of 20 characters, something like that. Then the second input type is another text, and it is for age. Its size is 3 characters because an age cannot be 5,000. And the maximum length that is allowed is 3. So it puts some condition. And then the third input is the version to purchase. And there are 3 radio buttons. One for small, one for medium, and one for large. And small, medium, and large are given numeric values like 150, 250, and 300. And then this page doesn't have a submit button, but assume that down below there's a submit button here. So the user types the 3 inputs, name, age, chooses one of these versions, and presses the submit button. So this last but one line says the next input is submit. And when that person clicks on the submit button, on click, you do this thing called check the information that is given in this form. So read this as checking for the information that is given in this form. And then there are some flags, is logged in and stuff like that, which we don't have to worry about. And then the form ends. So what is seen in the browser by an user like this looks at the web page in HTML somewhat like this. Now I want to test for this, bypass this and test. So if you see the input that is given, name, age, and the version to purchase, is checked here. If you see the second last line, it says when the user submits the button by clicking the mouse, there is this method check info of the data that is submitted that is called, and the value of that method is returned. This part is what we call client-side validation. I want to send wrong inputs through this form and bypass this client-side validation to check how the server responds. So what am I going to do? I'm going to use the same web page and fill some nonsensical input in the web page. So I'll write username is something like this. It has a special character greater than. Age, I will purposely give a number that is large, 500. That is impossible. So what have I violated? There will be implicit constraints in this method called checkinfo, which checks if a username is of plain text. That is, it contains only alphabets. I have purposely given a special character to see how the server will respond. Similarly, there will be a constraint in this method called checkinfo, where it will check whether the age is some number, let's say between 18 and 110. I have purposely given age as an infeasible number, 500. It cannot represent a realistic age. Now, I want to send this purposely wrong input to the server to see how the server responds. So remember, for a form like this, the HTML page beneath looks like this. And it takes the input and takes this method to check whether the data is correct. So I'm going to modify this by taking and storing the HTML file from the thing and removing some random parts of it. Let's say I'll remove this check for age. The parts that I have striped through, I remove this check. Similarly, I remove this whole method, call to the method checkinfo. So I Just don't do any client-side checking. Now, I want to see how, for this wrong input, after removing these checks, the server responds. So by striking out these or deleting these checks, what I'm doing is a client normally renders a HTML page, which upon accepting input will do some routine client-side checks to ensure that the data that is sent to the server is correct. By bypass testing, what I'm doing is I'm providing wrong inputs that typically violate the syntax, and I remove the checks like this that the client side does and send this data to the server. So I bypass the client side test. So that's the term bypass testing. So this is an explanation of that. Typically, web applications impose constraints on inputs through HTML forms. We just saw an example of that. Constraints can be two kinds. One is you write scripts, what we call scripts on the client side, which are basically programs that run on the client to check if the input data is valid or not before sending it to the server. The other is even plain HTML, you can write attributes to do several elementary checks. So you can use just simple HTML, or you can write scripting programs to check for more complicated constraints. The goal in bypass testing is to create inputs that intentionally violate the validation rules and constraints. And the created inputs are directly submitted to the web application without letting the web page validate them. Then you check what happens for the server responses. Client-side validation that is done routinely is bypassed. Modified data is sent to the server. This can be used to see if the server crashes. This is purely from the point of view of testing. Please remember that, right? This is before release of software. So it's okay to see on what kind of bad inputs the server could crash. So it's useful for checking security and robustness of response of the server. It also checks for common mistakes that users can make while writing inputs. So I hope you got an idea of how bypass testing, what is bypass testing. Now we'll see how to do bypass testing. So bypass testing can be done on the clients or on the servers. It basically modifies the input. You typically do it on the client side because it's safer, easier. Unless you work for a company that develops server-side software, we typically don't bypass inputs that are sent to the server directly. So on the client side, as I told you, you can validate several inputs. Several different types of input validation can be done using the good old HTML itself. Like for example, if you see this table, the first column of the table, I can set a maximum length for an input using HTML. I can give preset values. Like I told you, while typing the address, I could say state names as set of preset values. While typing gender, I could give preset values. Then I can set the transfer mode, get or post requests. I can set preset fields. I can set target URLs. All this can be done as a part of HTML itself. Suppose I'm using a scripting language, I can do additional checks. That's given on the second column in the table. I can check whether the data type is right, integer, a floating point number, string, single character, several different things I can check. I can check for data format. Like for example, in India, a postal zip code will have 6 numbers. In some other country, it can be something else. So I can enforce these constraints by writing small programs on the client side. I can check for data value, like we saw in that example. Age should be between 18 and let's say 100 or 110. Then, if you remember, if you've ever used credit cards for online transaction, you will see that many websites take your credit card number and they also take your expiry date and name. So I can check if the number of the credit card matches with the expiry date of the credit card and the name as given in the card set by the bank. This I can't do HTML, but suppose I'm using a simple scripting language to write a program on, I can check for these kinds of constraints. And security breaches happen by generating some special invalid characters. So I can write programs or client-side scripts to check for those kinds of invalid constraints. So typically these are routinely done as a part of client-side development of a web application, front end of a web application. In bypass testing, if I find such a check, I will violate it by removing that check and then send the modified data to the server to see how the server responds. Client-side constraints rules, this we already saw. I can violate size restrictions on strings. I can introduce new radio buttons, new values for drop-down lists. I can change the transfer mode, change the target URL, do several things. On the server side, I can convert data types, data formats, with several different things. I'd like to specifically highlight that security testing is an important aspect of testing web applications. And in the testing literature, it is known that these kinds of modifications to inputs are useful to identify typical security breaches. For example, I could replace a particular input by an empty string, introduce commas, introduce single or double quotes, introduce the tag symbols. In maths, they are less than and greater than. For programming in the web, they are the opening tag and the closing tag of a HTML file. I could change directory paths that lead to different files, different folders being accessed, full stops, ampersands, new control characters like new line, empty. All these things are problematic and they can result in security breaches in web applications. So I could introduce any of these characters as a part of my bypass testing and see how robust the server code is in terms of securely handling the inputs. A robust server code, when sent a corrupt input with one or more of these kinds of security violating rules, should be able to identify it as a wrong input and not respond or not crash. So bypass testing is a popular technique that is used for checking security vulnerabilities also. And specifically when we work with these kinds of characters, you can check by modifying inputs, by inserting these kinds of characters, you can check for security vulnerabilities using bypass testing. Yeah, so now how do I modify inputs? We'll spend a few slides understanding that. Remember, test cases to a web application are always HTML files, right? We saw that. HTML file is typically a static file or a dynamic file. And inputs to a HTML file are typically links. If I click on that link, it gives me some other data from the server, or I fill up a form. So a form unit is what we saw, that is a HTML form that specifies a server software component. And it gives the action. There is a particular thing called an action attribute within the form tag, which tells you what to do when a particular form is filled. And all the data that is filled as a part of the form constitute the HTML input. Like in that example that we saw, the name, age, version to purchase constitutes an input. If I'm searching for a particular product, the name of the product or certain keywords pertaining to the product constitutes the input that are sent to a form. If I am logging into an internet banking website, my username and password and maybe the CAPTCHA constitutes the form. So that's the form kind of input. The next is a link input, which is basically hyperlinks that tell you how a web page can lead to another kind of web page. And by clicking on that link, I'm providing an input. And I also specify implicitly, not explicitly, the transfer mode, which is a GET request or a POST request as a part of the input. Links typically get only GET requests. Now I have to choose HTML inputs or generate HTML inputs using bypass testing. We just saw that they can be forms or links, and a form can have many input fields, right? Like we saw, it has name, it has age, it has version to purchase. Sometimes you type in address, sometimes you type in CAPTCHA. So many different kinds of forms can be there. So if suppose I have to automatically generate all inputs to these forms, then it's obvious to know that the inputs can be very large in number. The minute I say name can be anybody's name, right? So how do I exhaustively generate inputs? And search, if I just have a search as a search button as a part of a form, you can search for anything. Like suppose I'm shopping on Big Basket, I can search for any product that I think Big Basket can offer. Suppose I go to the IIT Madras main page, I can search for a faculty member's name, I can search for a particular course, I can search for a particular department, admissions, lots of things. So, and we have to reduce the kind of information that we can span in terms of testing, because we otherwise cannot be exhaustive in terms of input. So exhaustive testing, exhaustive bypass testing for a web applications is never a goal. Because the number of different inputs can be very large. So typically what testers try to do is they look at a web page that they want to bypass and test, and then they remove redundant informations in the web page. Typically web pages contain two or more occurrences of the same search form, once at the top of the page, once down below in the page. So in which case they say, okay, this is the same form, but my input, I'm going to compose these two searches and make it as only one search button that I will bypass. So that way I don't have to bypass two versions of the same input. Similarly, some inputs can be optional. Like for example, suppose I don't choose, suppose I choose an age to be less than 60, then maybe some concession is not given. Concession is given only for senior citizens. So when I bypass, I am aware of this optional input that gets added, and I carefully generate my bypass testing cases. So even though per se the number of different inputs to a website can be large, and we typically don't consider our goal to be bypassing all those inputs, we still reduce the inputs by composing, eliminating duplicate redundant inputs, by considering inputs that are optional as purely optional, and so on, and then come up with a succinct reduced set of inputs. Now generate bypass test cases for those inputs. I will give you three kinds of bypass testing test cases that can be done. One is what we call value level bypass testing. That is what is given here. The next is parameter level bypass testing. The third one is control flow level bypass testing. So value level bypass testing basically modifies inputs to see how a web application adequately evaluates inputs that are invalid with reference to their values. Like for example, suppose a web page expects purely a string of numbers. Suppose I give it an alphanumeric string, how will it evaluate? Like we saw in that example, suppose it expects a name and I give it a name with a special character. How is it going to handle that invalid input? Suppose it's expecting a 6-digit code for PIN code, and I purposely give it a 5-digit code or a 7-digit code. That's also a value level bypass testing. Suppose it expects one of the values from the drop down menu, but I remove one of those values and purposely generate a new value by saving and modifying the HTML form. That's an example of another way of bypass testing. And as I told you, we can insert a whole set of special characters that could lead to security breaches, and see how bypass testing with these special characters can help to check how robust the server is. So you can modify values at value level bypass testing. The next is parameter level bypass testing. By parameters, what I mean is certain inputs can have more than one parameter. A classical example is when you're doing an online purchase, you use your credit card to buy, let's say, or your debit card to buy. Typically, you see a web page or a website will always take your credit card number, name, and expiry date. All these constitute one information about one card that have three parameters. If any of them mismatch, then the card is not accepted. So I can do bypass testing at parameter level to check for issues related to relationships between different parameters of an input. Again, because there are a large number of inputs and large kind of relationships, it's difficult to exhaustively determine all possible relationships. So we use our domain knowledge. We study the website that we want to test for bypass testing, and consider reasonable number of all possible input formats after applying I told you, right, the merging and other things. And then typically test for the trivial parameter level bypass testing that you can do is pass an empty parameter. Like you give credit card name, credit card number, cardholder's name and expiry, pass empty string for cardholder's name as one of the parameters, see what happens. Similarly, you could pass some universal pattern for all possible violations. Just change the date using a universal pattern for date and see what happens if that particular parameter is changed. Or you could keep valid values for all but one of the parameters, just change that and then see what happens. So these are generic parameter level bypass testing test cases that you can come up with. It's difficult to come up with systematic thing because it will heavily depend on the domain of the web application and the kind of parameter level parameters that the particular input has. Value level is for single values, inputs that have single values of various kinds. Parameter level is for inputs that have more than one parameter and they have a relationship, constitute an input together. The third one is control flow level. The classical example is, suppose I type in something, let's say my username and password along with a CAPTCHA to a web application, and the web app, because of slow internet or whatever reason, the web application takes a few minutes to load. Then typically as users, we get restless. We try to press refresh button or a back button and change the control flow. Remember, web applications deal with HTTP, which is a protocol that doesn't remember too much of history. So changing of control flow is another useful bypass testing technique. So control flow level bypass testing tries to verify web applications by coming up with test cases that change the normal execution. So we begin by identifying normal control flow. For example, in a internet banking application, normal control flow is type username, password, CAPTCHA. Then it'll come up with a welcome screen. In that welcome screen, you can do various options of banking, maybe do funds transfer, check balance, generate statement, whatever. Right? So based on the domain of application, you identify a normal control flow. And you could also parse through the code that is available for the front end to identify normal control flow. Sometimes it can get difficult if there are too many options, but you can identify normal control flow to a reasonable extent. And then you alter the control flow. You alter it by the typical example, right? By going back by one button at a state where it's not supposed to be going back, or by going forward by one link or hyperlink at a stage when it's not supposed to be going forward. Or you could do random control flow alteration and see how robust the server is for these kinds of control flow level bypass testing. This is a little more difficult to do than value level or parameter level, but if you are an expert, you could also bypass the control flow conditions. So this was a summary of what bypass testing is. Most of what I taught you in this lecture can be found in this paper. In case you are interested in reading more about bypass testing, you could refer to this paper or feel free to get in touch with me for more information. We'll continue with client-side testing in the next lecture. I'll stop here for now. Thank you.